Hey guys, we're talking about discontinuities in pre-calc class, and I thought we'd look at one function that sometimes I cover. I don't know this year I'm going to be able to get to it, but it's called the greatest integer function. It's a very unique function. First of all, it has a couple of different symbols. There's this X with this double bar, kind of a fancy bracket on either side. And right next to it, you can see an X where it's kind of like the absolute value symbol, but the bottom is kind of turned in. So those are the two symbols usually you see for this greatest integer function. It also has different names. Some people call it the round down function because it takes numbers and rounds them down. In computer science, they call it the floor function. So depending on your graphing calculator, it has different symbols. I happen to know on the TI-84, it's called the int function. You'll find it under the math menu. Anyway, what it does is this function just takes numbers and it rounds them down. So, as an example, if I had to, let's just kind of go back to algebra 1 where we come up with an XY chart. And of course, my Y coordinate is going to be the greatest integer of X. So what it does is it takes the X value and gives you the greatest integer less than or equal to that value. So if you put an integer in, you're going to get the same integer out. In other words, 0 rounds down to 0, and 1 would round to 1. But the function is interesting it's a little bit interesting when you have a non-integer. So for instance, 1.2 would round down to 1. 1.4 would round down to 1. But even 1.6 rounds down. It's not the rounding function, it's round down. Or it gives you the greatest integer that's less than or equal to that number. So even if you're at 1.999, it would still be 1. And then at 2, you jump up to 2. Okay, so that's not terribly interesting, but the graph is kind of neat. So let's show you what the graph looks like. So I'm just going to create my own coordinate system here with a couple perpendicular lines. There's my X, there's my Y. And like I said, the integers give you integers. So I could hit 0, 0. There's 1, 1. There's 2, 2. So it almost looks like the line Y equal X. And in fact, it continues on the negative side, -1. And you can see I'm not even using a grid here, but I really don't have to. -2, -2. So it really just looks like a series of dots with a slope of 1. But what's interesting is in between. In fact, I'll start plotting some of the points I have over here. Like, let's get all these strings of 1. So in other words, at 1.2, I would be at 1. At 1.4, I'd be at 1. At 1.6, even all the way at 1.99. And then at 2, I wouldn't have anything. I'd jump up to 2. And what happens is if you just kind of fill in every value, you're going to get basically a horizontal line segment right there. And will that happen with the other numbers? The answer is, of course it does. Like if you look at numbers between 0 and 1, 1/2 would round down to 0, 3/4 would round down to 0. So you'd have these same dots here, really on the x-axis. And then when you get to 1, you would have an open circle. So, 1, 0 is not in the function, but it's an open circle, right? The function goes right up to it. And this continues. This pattern continues indefinitely with, I guess you could say closed intervals or closed circles on the left and these open circles on the right. You can see here just like that, and it really goes on forever. As soon as you get to an integer, you bump up to the next integer. And of course, this goes on forever. We do what the English teachers do. We just kind of put 3 dots on either side, like to be continued. And that's, that's f of x equal greatest integer of x. That's the graph. And you can see it's discontinuous at every integer. right? It's got a lot of what we call jump discontinuities. Let's see if I can spell that correctly. U-I-T-I-E-S. At X element of the integers. So at every integer, you're going to have one of these jump ups. It's just a typical, actually, it's not very typical, but this is an example of a discontinuous function. Okay, guys? Hope that helps.